So, finding errors in data transmission, that's this week's video. But something that really has come to mind is when people find errors in other people, when people are constantly pointing out each other's faults. Stop doing this, it's so annoying. Find errors in your own self first, fix them first before you start coming after other people. Reminding myself first, obviously. Hi, welcome back. I'm Miss Zaineb, and today we were talking about finding errors in data transmission. There are a few methods which are shown here, but today we're going to be talking about parity checks, and I've got some exam questions towards the end so that we can go over them so that you're fully confident when you get to parity questions in the exam. Okay, so look out for my other videos for the other types of error detection methods. Enjoy! Okay, so a great comparison would be how do we detect errors as humans compared to how do computers detect errors. So if you look here at this statement, what you might need to do is actually pause this video and try and have a go at reading this. So if you pause it right now, welcome back. So you should have been able to read each of those words really easily. So this is actually by a study by Cambridge University in the UK, and the idea behind it is that you only, the power of the mind is that it can complete a sentence. All you got to do is do the first letter and the end letter, and if it's all mixed up in the middle, we should still be able to understand what is being read. So our mind does detect that there is an error. We do understand that there is an error in the word, but we're still able to get the message across. Computers don't work in that way. If there is an error in any type of data, then the computer basically reads it as an error, and it doesn't know, it hasn't no idea of what the data was trying to say. It can only detect that there's an error in the first place. So that's why it's really important to be able to have different methods in place that will detect the errors and then request that the data is resent again. So for your GCSE, you need to be able to know about these 4 different methods of error detection. Now, this video is only going to focus on parity checks, but like I said earlier, that there will be other videos coming for check digit, checksum, and automatic repeat requests. So today our focus is parity checks. As discussed in earlier videos, we know that data is sent using binary. So binary is made up of 1s and 0s. But how does the computer understand if what it's received is correct or if it was sent in error? Now, it may have left destination 1, it might have left the first destination complete, but maybe through a transmission fault, through a cut, or through any type of interference, maybe the data might have changed on the way there. So this means that there needs to be a check at the other end. There needs to be a check on the receiving end to understand whether this data is correct. So one of the checks here is when they add another bit. So remember that this binary code here is made up of 8 different bits, okay? Whether it's a 1 or a 0, these are bits. Even if it's a 0, it's still counted as a bit. So that last digit on the end that you see there, this is called a parity bit. This is sent in addition to the binary code. Now, this parity bit can, again, it follows the same rules as binary codes. It can only be a 0 or a 1. But how does the computer decide which parity bit to send? Well, it's actually quite simple, and it actually comes down to even numbers and odd numbers. So before data transmission must take place, the computer who's sending the data and the computer that's receiving the data must agree whether what they're sending is an even parity or an odd parity. So I'll say the computer or the laptop on the left is computer 1 and laptop on the right is computer 2. So if we have computer 1 and 2 have decided that it's going to be an even parity. So it can choose odd or it can choose even, but in this case this is even. So it's an even parity, and data will be transmitted. This is the same binary code as before. Data will be transmitted from computer 1 to computer 2. Okay, so the first thing that you have to do is really easy. You just have to count the number of 1s that are in the binary code. So we've got 1, 2, 3, 4, 5. The binary code still remains the same. This is just in terms of the check, we just count how many 1s that there are. Okay, so now we've got that information, let's flip back to our other screen. So this is our same binary on there. We count the 1s, so we said we have 5 1s that are there. Now, if we have 5 1s that are in the binary code, we know that the number 5 is an odd number. But as we said earlier, the computers have decided that they are doing an even parity. This then means that we need to put the parity bit as 1, or the parity bit needs to be a 1 in order to make the parity even. Because at the minute it's odd. Because it's got 5 ones, it's odd. So in order to make it even, we have to add another 1. So the only way that we can do that without damaging any of the data or without changing the data is then therefore we use the parity bit in order to do so. So therefore in this case, where we have 5 ones, it's odd. We want to make it even because we decided earlier it was going to be an even parity. So therefore the parity bit would be 1. So now when we count the ones, we've got 1, 2, 3, 4, 5, and then the parity bit would be 6, which would then make it an even parity. Now, if this was an odd parity, if the two computers earlier decided that they were going to transmit the data and it was going to be an odd parity, the parity bit would remain as 0 because we've already got 5 ones. Okay, let's try a really simple exam question. Okay, so this is a real exam question that has come up on in previous years. So parity checks are often used to check for errors that may occur during data transmission. A system uses even parity. Place a tick to show whether the following 3 bytes have been transmitted correctly or incorrectly. So in this case, the only thing that you would have to do in this case is count the ones. Really easy. So let's go with the first one. So we know it's an even parity because it says so in the question. So you have to make sure that you read the question very carefully. So this says it's an even parity, and then we need to count the ones. So let's do the first one. So we count the ones in that first byte, which is 1, 2, 3. So there are 3 ones in there, which means we know that 3 is an odd number. So therefore the byte is transmitted incorrectly. Okay, it's not asking you to add the parity bit on this one. It's just asking whether it's correct or incorrect. That's it. Okay, then we'll move on to the second one. So we count the ones in this case. It'll be 1, 2, 3, 4, 5. So that's an odd one. What you might want to do if you want to, if you actually get it, is to pause the video right now and try to do the last 2 on your own. Or you can just do the rest with me. Okay, so 1, 2, 3, 4, 5. That's 5, which is an odd number. So therefore the byte is transmitted incorrectly. And then lastly, you've got 1, 2, 3, 4 ones that are there. 4 is an even number, and therefore the byte is transmitted correctly. Hopefully you've got that one all correct. And we'll move on to something that's a bit more difficult now. Now this is quite a common question. This is where it asks you to locate the actual incorrect bit. So let's read the question. A parity byte is used to identify which bit has been transmitted incorrectly in a block of data. The word flowchart was transmitted using 9 bytes of data, so this is 1 byte per character. A 10th byte, the parity byte, was also transmitted. The following block of data shows all 10 bytes received after transmission. The system uses an even parity and the column 1 is the parity bit. Now, with using a block of data, this means that you've not only got to check for errors across, you've also got to check for errors going down in order to find that incorrect bit. So firstly, let's look at the parity that was decided. So it says in the question, an even parity was decided. And then it also says that column 1 is a parity bit. So let's make sure we can identify which one is column 1. And then you've got the parity byte, which is right at the bottom row there. That's the parity byte there. So we need to know these in order to identify which ones do we count when we are counting the ones. So first of all, let's start vertically, okay? So let's look at column 2. Column 2's got all zeros in there, so there's not much we can do there. Let's look at column 3. Okay, so column 3, we can count the number of ones that are there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the parity bit makes it 10. Okay, so then 10 is an even number, so it's an even parity. Do you also see that's a great example there, if you can see, of how they've added a 1 onto there to make it an even parity. Okay, so column 3 is absolutely fine. Let's move on to column 4. So 1, 2, 3, and then again the parity byte is added to make it a 4. This is an even parity, so that one's fine. 1, 2, this is column 5 now. 1, 2, 3, add another 1, that would be a 4, which makes it an even parity. And then we look at column 6. 1, 2, 3, 4, 5, 6, and then add another parity bit, which makes it 7. Now, we said that this was an even parity and 7 is an odd number. So we know that there is a mistake in column 6. So now we've got to find which bit is the mistake. Okay, so column 6, I've highlighted there. You can do that in the exam as well, by the way. You can highlight column 6 just so that you can remember when you come back to it. Okay, so now we have to look at it horizontally, and we've got to put our checks in place. So first of all, let's start with the first row. We've got byte number 1. So remember, we are looking for an odd number to find the mistake. So the first one, we've got 1, 2, 3, 4. That's correct. So that's fine. In byte 2, we've got 1, 2, 3, 4. Again, that's correct. That's fine. Byte number 3, we've got 1, 2, 3, 4, 5, 6. 6 is an even number, so that's fine. Byte number 4, we've got 1, 2, 3, 4, 5, 6. 6 is an even number, so that's fine. Byte number 5, we've got 1, 2, 3, 4. 4 is an even number, so that's fine. Byte number 6, 1, 2. 2 is an even number, that's fine. And byte number 7, we've got 1, 2, 3. 3 is an odd number. Okay, so 3 is not an even number, so therefore we can now identify where the mistake is, because you can see there that column 6 has been highlighted and now byte 7 has been highlighted, which then shows that this 1 is the incorrect bit. So the question will ask you which is the column and which is the row, and you can identify it right there. You can also identify it with the letter, so it's the letter A from the column flowchart. Hopefully that made sense, and if you need to go back in the video and just try and redo this question again on your own and then check it again, or you can go through some of the other exam papers and try and find some parity questions in there to get some more practice. So there are some issues with parity checks, and you need to be able to understand what they are for your exam. So first of all, let's look at this binary code here, and this transmission is under an even parity. So this is the same binary code as before. So we've got 1, 2, 3, 4, 5 ones. So we now know that we have to add a parity bit, and that parity bit would be a 1. Hopefully by now you'll understand why that parity bit needs to be a 1. If not, go rewind back on the video. Okay, so now let's say, for instance, that during the transmission, in some way, that 2 of the bits accidentally switched places. So you can see where my arrows are. So let's say that the ones and the zeros, this particular 1 and 0, they switched over, and this would actually create a brand new piece of data, because now the binary number won't read in the same way as before. So in effect, these 2 pieces of data actually read completely differently. Now, the issue that you have here is that it has the same number of ones. We still have 1, 2, 3, 4, 5 ones in that new binary code. Therefore, the parity bit that will be added on the end would still be a 1. But the issue is that the computer might not detect that there's an issue. However, when we add up what the binary number would be, so on the first one it would be 188, and on the second one it would be 185. These are completely 2 different sets of data. They read very differently, but unfortunately the computer won't detect it. The computer would still assume that this is the correct information because the parity bit has remained the same. It's still the same number of ones. It's just that one of the ones has been pushed into another place due to a data transmission error. So that is why we have the other transmission methods as well, and usually it always uses more than one, but then you do need to understand the limitations of each one. I hope you enjoyed that, and I hope it made things a little bit more clearer about how error detection works in transmissions. Be kind to each other, and I'll see you on my next video.